Let's take a look at number 12 from the Achieve homework in section 3.5. It should look something like this. They give you this function, and basically the coefficient in front of W here will vary depending upon the algorithm. So you could have a little bit different one, but it's basically the same thing. And you're asked to calculate H, and then in parentheses, there's a 2 of 1. So remember, this is notation for the second derivative, right? When you take a derivative of a function, you could, if you're taking the second derivative, right, you can use the double prime notation is one way, or you can use the in parentheses. It has to be in parentheses. If it's not in parentheses, then one other notation is the Leibniz notation. So that would be d squared h. In this case, notice the independent variable is w, dw squared. So these are all the same, represent the same thing. Okay, the second derivative of the function. Okay. X equal 1. So don't plug in x equal 1 until you have the derivative. Notice, first thing I would rewrite the square root of w is w to the 1/2. And you'll notice I have a product of two functions, w to the 1/2 times e to the 8w. So what rule am I going to use here? I'm going to use the product rule. All right, so the product rule says I take the derivative of the first function, w to the 1/2 times the second one, and then the first function times the derivative of the second one. Derivative of the first one, remember w is the independent variable here, so this is just power rule. I bring the 1/2 down. W to the what? 1/2 minus 1 is negative 1/2. Here we have the derivative e to the 8w. That's a chain rule, right? In general, if I'm taking the derivative with respect to, say, u of e to the u, I just get e to the u, right? But in this case, I'm taking, say, the derivative with respect to w of e to the u is e to the u times the derivative of the inner function, in this case with respect to w. So that's the chain rule, right? So I have, in this case, u is 8w, so the derivative of e to the 8w is e to the 8w times the derivative of 8w with respect to w, which is just 8. So here it is, e to the 8w times the derivative of the inner function. 8w derivative is 8. Okay, so cleaning this up, I get this expression here. I bring the 8 in front of these two. Okay, so there's my first derivative. Okay, now when I take the derivative of this, I'll get the second derivative, which is what I want. Of course, here I have a product rule here, and here I have a product rule. We'll look at the first one here. Again, take the derivative of the first function, which I'm calling 1/2 w to the negative 1/2 times the second, plus the first times the derivative here of the second. Again, derivative e to the 8w we've already done up above, so that's the same. This one, power rule, again, I take the 1/2 out as a constant multiple, bring negative 1/2 down, multiply. 1/2 times negative 1/2 is negative 1/4. Subtract 1 from negative 1/2, I get negative 3/2. Okay, so there's the derivative of the first part. Now the derivative of the second one, you can do the same way, but just notice this. Take a moment just to think before you go ahead here. I've got 8 times, and I've highlighted w to the 1/2 times e to the 8w. Well, if you think about that by itself, that's the original function, right? W to the 1/2 times e to the 8w, and we have the derivative of that function. It's right here, right? Well, right here, simplified, right? So I'm just going to take this whole expression here, and the derivative of this will be 8 times, right? 8's a constant multiple, times in parentheses, this thing just recopied, right? The derivative of w to the 1/2 e to the 8w. So again, it's using the product rule. Okay, so cleaning this up, and I've got this term here. I get 1/2 times 8 is 4. W to the negative 1/2 e to the 8w. Here I need to distribute the 8 through. 8 times 1/2 is 4. 8 times 8 is 64. So I can simplify a little bit in the middle, because you'll notice these are like terms. W to the negative 1/2 times e to the 8w, w to the negative 1/2 times e to the 8w. So I've got 4 of these guys, 4 of these guys. That gives me a total of 8 of them, right? So I can combine them that way. Okay, there's the second derivative. long and messy, crazy looking, but it's going to clean up very nicely when I plug in 1, right? So the second derivative h, second derivative h of h, again, this indicates the second derivative, evaluated 1, plug in w is 1. And you'll see what happens. 1 to any power is just going to be 1. And of course, e to the 8 times 1 is just e to the 8. So cleaning it up, you just have this. This is just multiples of e to the 8 power. So we can add this by adding the coefficients, -1/4 plus 8 plus 64. 8 and 64 is 72. And then I just put them over the common denominator of 4. 72 is 288 divided by 4. And then -1 plus 288 is 287. So I get 287/4 e to the 8th, which is the answer that they're looking for there. Just be careful. There's a lot of room for making mistakes in this. In fact, when I was doing this problem, you might notice a little interesting scribble there because I forgot the negative sign here. I didn't have the negative here. I didn't have it here. And so instead of doing -1 plus 288, I did 1 plus 288, and I had 289, right? 289. So, be careful, to carefully go back over your work, especially if you type something in and it's incorrect. You certainly want to take your time and show all support on a test or something so that I can give as much partial credit as possible for these. Okay, so hope this one helps. A little bit long on finding the derivative, but once we evaluate it, it goes fairly quickly. Okay.